So why the data-driven paradigm? And what is this data-driven paradigm? Let us try to understand this using a very simple example. So let's say we have these handwritten digits 1 and we want to write a program to be able to decide if it is this handwritten digit 1 or it is not. Now let us say that inside our computer these handwritten digits are represented as a 28 cross 28 2D matrix. Yes. So we have these 28 rows all the way from 1 to 28 and we have these 28 columns 1 to 28 and some of these pixels, right. So let's say this is our 2D matrix and this is of size 28 cross 28. Why 28? We'll come to that later, but let's just play along. And now, so all of these are, let's say, zeros except for certain pixels which are, let's say, 1, right. So this is what then is our representation of this handwritten digit 1 inside our computer. And suppose we do not know of any machine learning, we do not know of any deep learning, and we want to write a hand coded program to be able to do this. So we want to write a function, let's say some function func where the input is this matrix A, and as a return in the end we want to return a yes or a no, right. And we have to write a program, and we know how to write like for loops, we know if then else's, and using this we want to write a program. What would you do? So probably you would write a program and you would say, oh, I would check if my a of I comma j is equal to 1, and then I would check what is, let's say, my I plus 1 comma j, so the pixel below it, and based on this we will write some hand coded program, and probably it will work to certain extent. But remember, some of our hand coded digits are slanting, some of them may even write our 1 differently. They might write a 1 such as this, and then we also have to deal with this. And let us suppose that we are still able to do this, right. So now our A might look like this, and let us suppose we are able to make our program even more complicated by adding more lines of code. Maybe we have, say, 500 to 1000 lines of code in the end, and we are still able to write a program with which we are able to tell if it is a handwritten digit 1 or not. So great, well done. But let us now assume that it may so be the case that we want to now do it for this handwritten digit 2. Yeah, and when we want to do it for this handwritten digit 2, what do we do, right? Like now our handwritten digit 2 is similar. It is again these 2D arrays of 28 cross 28. And even here the white pixels are, let's say, represented by 0, and the black pixels are, let's say, represented by 1. So our matrix A in this case would look like all zeros, but then we have maybe 1 at certain places, right. So maybe our 1s look like this and everything else is all zeros. And now here I want to again write a hand coded program to be able to take in this array A. So I want to write another function, let's say some function which takes in this A, and as return I want yes or no. So in this case, what would you do? Now you see this is getting complicated. You might say, okay, let us try to fit curves, let us maybe try and see and write a more complicated program, and you can try, but it will become very, very complicated very, very quickly. And this is the point that I'm trying to make, that like with 1 it was already a little hard, and now different people write 2s differently. So now if you were to write a program to be able to do this using a hand coded program, it is hard. And now you see where I'm going with this. Like now suppose I want to do this with, let's say, a cat, an image of a cat. then how do you write that hand-coded program? And when it becomes a colored image, our image is represented not just with a 2D array, but then there are also channels to it. So it becomes actually a 3D array. So we have our 2D array A, which looks like this, but then we have, say, 3 channels corresponding to red, green and blue in this case. So for the first array represents, let's say, red and then green and then blue. There are different ways to do this, but let's assume this is the case. So let's come back to our case of 2, and let's say I have a very simple idea of what I want to do. What I want to do is I want to take all these. So this is my data set, and I will keep a few of them, let's say all the way till here, and I will call this my training set, and I will call this as my test set, and we will talk about what I mean by my training set and my test set. Training set essentially means the images that I use to train my model, and we will talk about what I mean by train, and the test is to then test the model that I have trained. Right? And the very simple approach that I want to do is I want to take all these arrays of size 28 cross 28, right? Let's say how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 training images, and let's say 2 test images, right? So I want to take all these 9 images written by different people, or and simply take an average of all these arrays. Yeah, and that is my machine learning model. So what will that average look like? What do you think? What will the average image look like? So the average image will actually look something like this, right? So this 2 actually is nothing but my average of 1 over 9, because I used the first 9 images to do this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And what I have done is I have simply averaged the sum of each of my images of A of I comma j element wise, right? So all I did was, for let's say the pixel here, I took the last element of all my arrays, and so let's say 28 comma 28, and I averaged it, right? So I divided by 9 of all of them from the first image, and then plus for the second image of 28, 28 and so on. And I did this for all my pixels, yeah? And this is how I got each of these pixels. Yeah? So if you want to write it formally, you can say that your I comma j of my average image, let us call it A mu, is nothing but my average. So 1 over 9, because we are doing it for 9 images, of all my A of I comma j of my kth image. So here I would say k, and k equals 1 to 9, because I will go from k equal to 1, so that becomes A of 1, and then k equal to 2, which becomes A of 2, and so on. So this is just us writing it formally, but and so if we are very easy to write a program for this, and in our previous Python introductory modules, you would deal with NumPy. With NumPy, you can vectorize it, you can do it using a single line, it's more efficient, but you have already seen that in our pre-read material. And with this, what we are able to do is we are able to get this average image. Yeah, and I'm calling this average image, remember, by A mu. Yeah, so this is, again, what size is this? This is an array of size 28 cross 28, and what does it look like? It looks like this, this blurred 2. Why? Because different pixels were at different places in our data set, and when we average all these, it looks like 2. You will also have a hands-on lesson for this. So your TAs will help you achieve this goal, but this is one of the very simple exercises that we will do, where we will do this average and look at what this average image looks like. Now that we have this average image, what can we do with this? What do you think? So now what we can do is, we can take this average image and use this as our model. So we can rewrite our function that we were trying to write, and to this function I already pass this average image, and in addition I pass the image that you want to recognize, and then I will say yes or no based on my A mu. And how will I do that? I will compare. So I will compare my A mu and A somehow. right? We will talk about how to compare. We can do a so-called cosine distance, we can do a so-called L2 distance, but we don't need to worry about that. The point that I'm trying to make is we created a model. This is the simplest model. There are no so-called learnable parameters. We'll talk about that. It is just an average. In statistics, it's the first mode of your distribution. So we have this average image. We use it in our function to then recognize an image that we have if it is a handwritten digit 2 or not. And we do this as a hands-on exercise, and you will see this later in the course. It will be one of the homeworks that we need to work on, and we will have the TAs help you with that if you need any help during the office hours. But this is essentially the first data driven. Realize it to, let's say, a cat, but it will not work with a cat because cat can be very different, and so we will see next what to do when we have, say, a so-called cat, if you want to recognize if it is an image of a cat or not a cat. So the message here is the data driven approach. Why is it called data driven approach? Because we use data to then create our algorithm. And why data driven approach? Because sometimes the algorithm becomes so complex, like in the case of trying to fit curves or writing these hand coded programs, which can be hundreds and thousands of lines of code. You can do it in a much easier way if we resort to data. Yeah. So in this case, we have kind of seen why do we need to do the data driven approach and what is that data driven approach in a very simple way, where we do not have any learnable parameters, where we simply create the average of the image and use that as our model.